Hello, my amazing students. This is Mrs. A, and we are doing 5.2 homework help. And the first problem is number 5. And number 5 says, the Y-sort method of gender selection, developed by genetics and blah, 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 was designed to increase the likelihood that a baby would be a boy. When 291 couples used the Y-sort method and gave birth to 291 babies, the weights of the babies were recorded. So what we're trying to do here is determine whether this is or is not a binomial distribution, or a distribution that could be treated like a binomial distribution. It says for those that are not binomial, identify at least one requirement that is not satisfied. Well, on this one here, number 5, they're talking about recording the weights, and the weights would be a continuum, not a discrete number of outcomes, and so that right there would disqualify it. Also, the weights of a baby are not just 2 options. So if they were recording the sex of the baby, then I would say yes, it could be binomial. But they're recording the weights of the baby, which is a continuous variable and not of just 2 options. So that would be number 5. So the next one is number 13, and it says guessing answers. Okay, standard tests such as SAT, ACT, or medical college exam test typically use multiple choice questions, each with 5 possible answers, A, B, C, D, E, one of which is correct. Assume that you guess the answers to the first 3 questions. Use the multiplication rule to find the probability that the first 2 guesses are wrong and the third is correct. That is, find the probability of wrong, wrong, correct, where wrong denotes a wrong answer and C denotes a correct answer. The B portion of this one says, beginning with wrong, wrong, correct, make a complete list of the different possible arrangements of 2 wrong answers and 1 correct answer, and then find the probability for each entry in the list. And C says, based on the preceding results, what is the probability of getting exactly 1 correct answer when 3 guesses are made? Okay, so it says up here in the instructions, it says in exercises 13 and 14, answer the questions designed to help understand the rationale for the binomial probability formula. Okay, so this one's pretty easy. The first one in A, they ask us to give the probability of WWC, or wrong, wrong, correct. And since there's 5 choices for each one, A, B, C, D, E, there's a 4/5 chance of getting the first one wrong, a 4/5 chance of getting the second one wrong, and only a 1/5 chance of getting the third one wrong. So when we multiply those all together using our multiplication rule, we get 16 out of 125, which turns into 0.128 when we write it as a decimal. That is the correct answer. For B, all they wanted us to do was write all the different ways you could get 2 wrong and 1 right out of 3 guesses. And so they gave us the starting one, WWC, so all we have to do is move the C to the other 2 positions. And each one of those is the same thing as this one here. So each one of them has a 0.128. And then it says, what is the probability of getting 2 wrong and 1 right out of 3 choices? And so it could happen in any of the ways that we saw in B. Therefore, it's going to be 3 times 0.128, or 0.384. So that one was pretty straightforward. Okay, so we're doing number 23, and I wanted to do it for you both ways. It says, of 10 users, what is the probability that at least 8 will use the phone in meetings? Okay, so it showed that the probability of an owner of a cell phone using it during meetings and classes and whatnot is 54%. And it says, what is the probability that at least 8 will use the phone during the class time or the meeting out of 10? So I did it first using the binomial formula, using the probability of 8, the probability of 9, and the probability of 10, which is what it means to have at least 8. We'd have to have all 3 of those probabilities added together. And remember, our binomial probability first has the combination in the front. So I've basically done each one of these here. It's got the probability of success, which here we're calling success, them using the phone in the meeting, so 0.54. And then we're going to put the 8 and the 2 because remember, this number here on your combination, this is going to be your total number, 10 users there. And then, so we put the 10 on the top. The 8 is what we're doing right here. So we put the 8, and then these 2 numbers on the bottom always add to the 10. These the same numbers that you use over here as the exponents to your success, 8, and then failure to the second power. So when we do all of that, that gives us the probability of 8, and then the probability of 8 is over here. When I multiplied it out, is 0.06885. I did the same thing for probability of 9 using the binomial formula. When I finished with that, I got the probability of 9 was 0.01796. Then I did the probability of 10 using the same formula. I got the probability of 10 was 0.00210. I added all of those together, and I get the probability is 0.0889. Okay, so then I decided let's do the same thing on the calculator. Okay, so I took binomial CDF, and when you're using the binomial CDF, you're going to put down your 10 for the total number of trials. Your 0.54 is your probability of success. And remember, your binomial CDF, all of your functions are going to take it to the left of the number that you want. So since we wanted 8 or more, we're going to only let our leftmost part go up to 7 because 8 is in our problem. So we're going to go all the way up to 7. The probability was 0.91109. I'm looking for the probability of 8 or more. So I'm going to have to take that away from 1, and I get 0.0889, which is exactly what I got when I did it the other way. So that is problem number 23. All right, number 15 is the next one, and it says that we are to find the probability that the number x of correct answers is exactly 7 out of 8 trials, and the probability of success is 0.2. So we're going to apply our binomial again, and here it is. Okay, the probability of exactly 7 correct out of 8 is going to have an 8 factorial over a 7 factorial times a 1 factorial. And then over here we got 0.2 is the probability of success raised to the 7th power, and 0.8, which is the probability of failure. Remember, the probability of failure is going to be 1 minus the probability of success. So 0.8 raised to the 1 power. When I calculate that all out, I get 0.0008192. I actually got the funny little exponential there, and I had to move my decimal, so that's why it looks funny like that. And that is the correct answer. All right, so here we go with number 29 and the last problem on 5.2. We have 36 couples, and they're using this XSort method for getting a girl as a result of pregnancy. And we're supposed to find the mean and the standard deviation of this binomial situation. So the probability of success is the probability of having a girl. And since they're assuming that the method has no effect, we're going to say 0.5 is the probability of getting a girl. In other words, it's equally likely, boy or girl. So n is 36. Now, remember this formula. the mean of a binomial distribution is n times p. So 36 times 0.5 is going to give you 18. We should expect 18 girls. That's the mean. The standard deviation is the square root of npq. Remember, if p is 0.5, then q, which is 1 minus p, is also 0.5. And then we get 36, which is n, times a half, which is going to be 18, times a half again, which is going to be 9. Then we take the square root of 9, and we get 3. So we end up with our mean is 18, and our standard deviation is 3 girls. And that is correct for A. So there's your A page. Now let's go on to B. In B, we're supposed to use our range rule of thumb to determine if we have a significantly low or high, what those regions would be. So we're going to take the mean, which is 18, and add 2 standard deviations, which is 2 times 3. So 18 plus 6 is 24. 18 minus 6 is 12. So we would say that values of 12 girls or higher are going to be considered 12 girls or fewer will be considered significantly low, and 24 girls or higher will be considered significantly high. Based on this, in Part C, we are to determine whether the result of 26 girls is significantly high. Since 26 is to the right of 24, we would say yes, 26 girls would be significantly high, which would be an indication that the XSort method is effective because we got more girls than we would expect. And that is your 5.2 homework help. I hope that it's being helpful for you, and I will see you again soon for 6.1 homework help. This is Mrs. A, and may God bless your day.